Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be energy, work and power. So first up, what is energy? Energy is just the capacity to do work, to create a phenomenon, a happening of some sort, and the SI unit is joule. You may ask what kind of work. Work takes the shape of all kinds of activities we will explore now. So before we look into the physically expressed energy, so we will look at different types of potential energy. First, there will be chemical potential energy, where it comes from things like food, from fossil fuels and batteries. And if you are well versed in the subject of chemistry, you will know that the chemical potential energy that's talking about here is the energy that's stored within the bonds of atoms, and then if you break them apart, energy is released for it to do work. So in the case of food, if you eat a burger, the protein, the starch molecules that are inside, they are all bounded by bonds between atoms, and then if they are broken, then the energy is released. So I like to tell my students that you're eating bonds. So same for fossil fuels, they have long hydrocarbon chains, and because they are long hydrocarbon chains, there are numerous bonds down there, carbon to carbon, carbon to hydrogen. You break them apart, the energy gets released. Okay, next will be elastic potential energy, things like bow and arrow, like the crossbow, catapult. So before the object is being released in that stationary form, the elastic potential energy is there, ready to go. So this is something you should be pretty familiar with. Gravitational potential energy. Gravitational potential energy is just the object experiencing the gravitational pull if it gets released from a certain height. So we will check it out later that the formula for gravitational potential energy requires the unit of height in it. So if you think about it, gravitational potential energy and the elastic potential energy is pretty much similar, but it's just that one is a downward force. The gravity one is the downward facing one. So it's like gravity is like a bow and arrow pointing downwards. So it's pretty similar, but it's not the same. Okay, so now let's look at the physically expressed energy. Electrical energy, lightning, things like that. Light energy, heat energy, sound energy, okay, nuclear energy as well. From fission, fusion, things are being smashed together or taken apart, energy is being released. So electrical, light, heat, sound energies are pretty commonplace that you should have been experiencing them by now. Okay, so next we go on to principle of conservation of energy. So it states that energy cannot be destroyed, cannot be created, but it's just converted from one form to another. So the total energy within that phenomenon, the activity, or in science we call it the system, is constant. So like hammering a nail, there is gravitational potential energy, so it goes down. There's kinetic energy, so it's used to drive the nail down. More kinetic energy, more force, right? And of course heat and sound will be produced. So not all the energy from the hammer goes into the nail. So you need to be able to appreciate this fact. And in secondary level, usually the wastage of energy from one point to another usually is expressed in terms of heat and sound, and in some rare cases also light. So principle of conservation of energy in a pendulum, if you displace it to a certain height, it will swing, release it, and then it will swing down. The gravitational potential energy is converted to kinetic energy. Since energy cannot be created, cannot be destroyed, it just transforms from one version to another. The kinetic energy is converted back to gravitational potential energy as it gains in height on the other side. However, this is not the case because there is things like air resistance. There's air particles surrounding the pendulum bob. Therefore, it will slowly reduce the height gain on the other side. Each swing by a negligible bit, each swing, but it all adds up together. And because energy is not destroyed, it just gets transformed. So what does it transform to? And you guessed it, heat and sound. Heat energy is a little bit of heat energy is produced when the pendulum bob hits the air molecules as it passes through the air, and of course a little bit of sound. And therefore that brings us to efficiency. So if you input 100% of energy into a certain system, and on the other hand you get only 98% on the other side of this pendulum bob, then therefore this end you have lost 2% of energy transformed as heat or sound. Therefore, the efficiency will be 98%. This is simply worked out in your mind, but there is a little formula down here, which is quite common sense. And energy part is done. Let's talk about work. So work done is defined as the force and the distance moved by the object in the force's direction. So if you push a wall, the wall is stationary, there's no work done, even there's a lot of force being applied. But if you are pushing a bicycle, then yes, you're pushing the bicycle through a certain distance. Work is being done to overcome friction, to overcome air resistance, things like that. And it is also commonly used to describe energy conversion. So this part is one of the key skills. SI unit for work done is also joule. It's the same as energy. It is equal to energy being transformed from one version to another. So if you are talking about carrying books, even you are stationary, there's no work being done upwards because there's no distance travel. And even if you're walking, there's no work done on the upward direction because you're not raising the book upwards. But yes, there is work done in the forward direction if you're walking with some books. So kinetic energy is bounded by this formula. So Ke equals half mv square, and using the units of such, as well as gravitational potential energy is bounded by this formula Pe equals to mgh with these units. So sometimes when questions like to ask, there's a ball on a slope and it rolls down the slope, it is assumed usually that all the potential energy will be converted to kinetic energy. So you can straight away state Pe equals to Ke, things like that. And in the sample questions later, we'll talk about how to merge formulas together. And lastly, we will be talking about power. Power is just the rate of work done, or the rate of energy conversion, because work done and energy conversion is pretty much the same thing. And because the word rate is there and it is a time sensitive word, therefore it is bounded by this formula called power equals to work done over time or energy converted over time. And the unit will be as such, SI unit as such. So we talk about power lifting by a strongman, and they are usually lifting a very, very heavy load through a certain distance in a very short period of time. That's why it's called power lifting. So if you're high power, you are able to do a lot of work in a short period of time. Okay, so now let's look at some questions and see how things come together. Ball of this mass rolls down a hill of this height. At this point, the speed is this, gravity is this. So ignoring the effects of friction and resistance, air resistance, what is the kinetic energy at the bottom of the hill? So at this point, there's certain energy down here. There's GPE, there's KE, and at the bottom of the hill, all the GPE is going to be converted into KE. So you just find them all out and add them all together. It will just be like that. And just to reiterate that in physics, formula is very important. Just dump the formula, see the question, do extraction. Extraction means to find out all the units. Throw formula, dump everything inside, and bam, you will get the answer. Some students climb stairs at school. Weight and time are recorded. Who has the most power? So power is defined as the work done over time. And if you're heavier, you're carrying a heavier load upwards. So they all climb the same set of stairs. You can ignore the distance. So you just have to find out who carried the heaviest load up in the shortest amount of time. You can just divide accordingly and you will get the answer. So same, it's a flight of stairs, and usually for questions about stairs, they are concerned about the height, they are not concerned about the distance, the horizontal distance travel, because the objective of stairs is to gain height. So the useful work done will be just the vertical height, 600 Newton by 3 meters moved will be 1800 joules. Okay, a ball is at point X, falls under gravity to Y and to Z. Distances are shown. What is the ratio of kinetic energy at Z and kinetic energy at Y? So assuming that all energy from GPE is converted into KE, you can formulate the equation as such, and therefore you put one above the other, you'll get the answer, that is 2. Body mass of 50 kg falls freely from a height of 20 meters. Gravity is this. What is the speed? So same, P equals to mgh, or rather you can just use Pe equals to Ke. You throw out all the formula, you sort everything inside, you equate, and you get answer. Lorry is traveling, okay, force is this, power produces this. How far does lorry travel in 1 minute? So this you need to work backwards. They give you the final answer of power. Power equals to energy converted over, or rather work done over time. So you get the work done involved. Work done equals to force times distance. The force is given. Now you can find the distance. And lastly, force F is used to pull a box weighing 20 Newton up a smooth incline. What is the minimum value of F needed to move the box up the slope? So there's force, there's distance, Over here is a Pythagorean triangle. Gain in GPE will be this. And work done is force times distance. It will give you 12 Newton. Okay, let's look at this unique written question. So a clock whose face is vertical has this information. What is meant by work? So this is just a definition question. You need to know your definition as well. It's always commonly asked. So calculate work done in lifting the minute hand from vertically downwards to vertically upwards. So it has a CG at this point to a CG at this point. The distance traveled will be carrying this mass from here to here. Work done equals to gain in GPE. It will be mgh, which will give you this. So calculate the average power. Power is energy converted over time. Time from vertically downwards to vertically upwards is of course 30 minutes. So use your information previously and you divide it over time. You'll get this. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!